Good day, students. In this video, we are going to see what is Epsilon NFA, what is Epsilon closure, and how to remove this epsilon from an NFA and we can convert it into an NFA without an epsilon. So, what is Epsilon NFA? So, before going to see what is Epsilon NFA, let me give you a small brief about what is NFA. NFA is a non-deterministic finite automata. In finite automata, there are of two types, deterministic finite automata and non-deterministic finite automata. In deterministic automata, finite automata, for each and every state, we'll be having like an, for a single input, there will be like a single output likewise. So if you have an input of 1 or 0 in a state, we may know very determinately what will be the next state. Whereas in non-deterministic automata, it's not the case. For an input, it can have like more than two-way possibilities. So here you can so that is the difference between an NFA and a DFA. An NFA with a transition is that even without an input in a particular state, we can transfer from one state to another state. That is possible using an NFA. Here, without an input, the term is being symbolized as epsilon in our mathematically. So this is an example of an epsilon NFA. So here, if we are writing this epsilon NFA into transition diagram, like our other transition diagram, we'll be including 0 as one an input and also the epsilon as an input. So here you can see that in Q0 state with an epsilon as an input, it transfers to Q1. So that's what written here. And in Q1 state with an epsilon as an input, it transfers to Q2 state. That's what written here. And from here, it is not going anywhere. So only the 5 is being written. We'll find the epsilon closure of this particular diagram in a short note. So first I tell you what is epsilon closure. So to remove this epsilon from an epsilon NFA, we need to find the epsilon closure of each and every state. So what is an epsilon closure is that epsilon closure for a given state is a set of state which can be reached from that particular state with the null input until the end. So for example, here you can see an typical epsilon NFA diagram where this is the start state and this is the end state. Okay, and here you can see with an epsilon as an input from Q0, it can jump from Q0 to Q1, Q1 to Q2, Q2 to Q3. Am I right? So here the epsilon NF for all these particular state, we can find the epsilon closure. So how we can find? Let us find for all the state. Epsilon closure of Q0 is equivalent to, usually the epsilon closure of any state will be the state itself. So first we have to write it Q0. Then from Q0 it's going to Q1. So it could be Q1. Then from Q1 it goes to Q2. So it's going to be Q2. Then from Q2 it goes to Q3. So it's going to be Q3. And also from Q1 it also goes to Q4. So we can't miss this also. So comma Q4. I think you understand the tricky part. So from Q0, if we take this route, it may go over there. If I'm taking the epsilon this route, it may go over here. So that also be included. So let's find the epsilon closure of Q1. First the state itself Q1, comma. So from Q1, it goes to Q2. So Q2, comma. From Q2, it goes to Q3. So it Q3. No other diversion, so leave it off. So from Q2, first Q2 itself. So Q2, comma. From Q2, it goes to Q3. So Q3, from there is not any transition. And in Q3, there is no epsilon, but epsilon closure of any state itself. So we should put it as a Q3. You should not put any phi and all over there. Then in Q4, from Q4, there is no transition. So put Q4 there itself. So Q4. So in Q5, we have a jump, that is Q6. So first write the same state. So that is Q5, comma. From Q5 it goes to Q6. So it is Q6. From Q6 it's not going anywhere. So simply Q6. So this is the epsilon closure for this given epsilon NFA. Now let me go back and we will find the same epsilon closure for these three states. So from here Q0, First the state itself, so Q0, comma. From Q0 it goes to Q1, so Q1. From Q1 it goes to Q2, so Q2. So from there it's not going anywhere, so fine. Again for Q1, the state itself Q1. From there it's going to Q2, so it's Q2. Okay, finally it's a comma. And in Q2, there is no transition, so put the Q2 simply. Okay, so this is to find the epsilon closure. This is the first step to eliminate the epsilon from an NFA. I hope you understand this. Now we will have an example of converting a epsilon NFA into NFA without an epsilon. That's a very simple task. So given is an this is the epsilon NFA, and for this epsilon NFA I have tabulated before itself. So this is the start state, this is the end state. So with an arrow and a star I have represented. So it has an input 0, 1 and 2 and also epsilon. So 0, 1 and 2 I tabulated with an epsilon. There are so many null states, so without any input, so I have represented over here. Okay, so now we are going to convert this into this without an epsilon. The first step is that we need to find the epsilon closure for all these states. So epsilon closure of Q0 is first Q0 itself. Then from Q0 it goes to Q1. Am I right? So Q1. So from Q1 it goes to Q2. So Q2. Good. Now from Q1 the state itself. So Q1. Then from Q1 it goes to Q2. So Q2. Okay. Then for Q2, nowhere it's going. So simply Q2. Okay. So first we have to find the epsilon closure for all these states. Then what we have to do is that for each and every state, we need to find the extended transition function. I hope in my previous explanation of DFA, I would have given briefly what is this extended transition function. It is simply a way of writing and finding what happens from a state if an input is given. For example, in a Q0 state, if an input 0 is being given, where it goes. So in a Q0 state, if an input 0 is being given, it is go to Q0, but it is bind with epsilon. So what we have to write it as epsilon closure of delta Q0 comma 0. So which is equivalent to epsilon closure of so delta Q0 comma 0 is in Q0. If the input is 0, it's going to Q0. So Q0, which is in turn is equivalent to epsilon closure of Q0 is Q0, Q1 and Q2. So Q0, comma Q1, comma Q2. Likewise, in Q1 state, when the input is 0, it is 5. So if you're finding 5 for anything, it's always going to be 5 only, the empty state only. So we just put empty state over there. We don't want to waste our time because in Q1 it is 5, says epsilon closure of 5 is always going to be 5. Likewise, in Q2, when it is 0, it's going to be 5. So we just put 5 over there. Now, in Q0, Q1 and Q2 state, for the input 1, 2, and for the input 1, what happens? So here, with the input of 1, it is again 5. When it is input is Q1, 1, it is Q1. So, E closure of your Q1, this Q1 will be equivalent to E closure of Q1 is Q1 comma Q2. So, it is Q1 comma Q2. Okay. Again in Q2 with respect to 1 it is going to be simply 5. So 5 I have given. Same way in this state with the input 2, first 2 is 5. It's not going anywhere. So it is going to be 5 and 5. Whereas with respect to 2, with the Q2 it goes to Q2. So epsilon closure of Q2. Epsilon closure of Q2 is Q2 we have already found. So it is Q2. So now we can fill this answer table. So in Q0, Q1 and Q2, when the input is 0, it goes to first one Q0, comma Q1, comma Q2. Whereas for all other input, it goes to nowhere, so 5. So with respect to 1, all the state goes to 5 q1 comma q2 and 5. Again with respect to 2, 5, 5 and q2. So now what we have done? So this is our epsilon NFA. We convert this epsilon NFA into an NFA without an epsilon. So we have converted an epsilon NFA without an epsilon by combining few state. How we combined it? With the help of epsilon closure, we have converted a epsilon NFA to NFA. Hope you understand this concept. Thank you.